Welcome, everybody. We will give you just a couple of minutes to log in before we get started. Those just joining, welcome. This is Research and Discovery Grand Rounds. We'll get started in just a minute. We're giving folks a moment to log on. All right, we will go ahead and get started. I see we still have some people joining us, but I want to make sure we leave plenty of time for our speaker today. Welcome. Again, this is Research and Discovery Grand Rounds. Thank you all for joining us today. My name is Ashley Carlson. I'm the Director of Research Training and Communications at KU Medical Center and the Education Navigator for Frontiers Clinical and Translational Science Institute. This is the first of our spring semester Research and Discovery Grand Round sessions. This semester, or this year, we're taking a slightly different approach and grouping some presentations together around a common theme. And for spring, we are focusing on harnessing big data, AI, and emerging technology to advance discovery and innovation. We are here for our first session, which I will introduce here shortly, but wanted to put the other sessions coming up in front of you. In April, we'll hear about AI-driven wearable interventions. And in May, we will be talking with Don King about AI in clinical and translational research. And in June, we'll be hearing about big data and precision medicine with Diego Robles Mazzati, who works with All of Us Data and Research. And those details are all available on the Frontiers website. So if you haven't yet, I highly recommend visiting frontiersctsi.org to become a member and see our calendar. So I'm going to stop sharing. And I am pleased to introduce our speaker today, Mark Hoffman. Dr. Hoffman has served as the Chief Research Information Officer at Children's Mercy Hospital for 10 years. As part of his Oxbridge BA in molecular biology at William Jewell College, he studied bioethics at Oxford and then earned his Ph.D. in bacteriology at the University of Wisconsin-Madison. He completed postdoc training at the USDA National Animal Disease Center before shifting to informatics by joining Cerner as a software engineer. Before returning to academia in 2013, he served as Vice President for Research and Genomics at Cerner Corporation, where he originated concepts related to the integrating genomic information and electronic health records. He is an inventor on 25 issued patents and is a fellow in the National Academy of Inventors. Dr. Hoffman is an expert in research using aggregate EHR data and is an MPI on an R01 focused on applying national EHR data to examining fungal infections. He is co-lead of the Frontiers Informatics Core, and his team has developed applications used at CMH and KUMC. In his spare time, you might spot him with binoculars tracking down a life lister, bird or animal. Thank you, Dr. Hoffman, for being here today.
Great. And can you confirm my sharing looks good?
Looks good.
All right. Thank you for the invitation to speak today. I'm looking forward to touching on a variety of topics and projects. Um, so I'm going to share a little bit about my data and AI journey. At the end, we'll talk about some technology that our team has developed to enable this journey. Um, I'll admit that the harnessing title was assigned. It's not a word I naturally use, but it grew on me as I reflected on the current landscape. My second disclaimer is I like horses, but I'm not a horse person. Um, but when I thought about what a harness is, it's straps or fittings that are fastened to a cart or plow and a horse to control it by the driver. I thought about what is the opposite of a harness, of harnessing, and it's unleashing. And so we're going to talk a little bit about are we seeing a lot of unleashing right now in AI and data and technology, and how can we kind of find that right balance between harnessing and unleashing? I don't have any current stake in any of the companies that I'll mention today, and I do currently have NIH funding. So let's start with talking about data. My and Ashley in the request to speak asked that we speakers share a little bit about our background and our career journey. My data journey began as a bench researcher, so I did spend a period of my career actually generating data in microbiology and immunology. But then I did make a sharp pivot to technology development, joined the electronic health record industry where I worked for 16 years, leaving as a vice president. During that period, I um, was involved in multiple large-scale data initiatives. In 2001, I was involved in a public health initiative that I'll share a little bit about. I realized that as a recycler, a lot of what I do in technology is try to recycle a capability in one area and apply it to another. In 2009, I took that similar mindset to a national disease surveillance initiative. 2013, I moved back to academia, began leading work as a user of the massive EHR data systems that I designed, developed, and led during my work at Cerner. Around 2019, I began sharing concerns about data quality, data representativeness as inputs into AI. So I'll give you a preview. I am going to rain a little bit on the AI parade during some of my comments, but I'm going to loop back and show why I still think it's important and necessary to keep progress in AI. And then around 2023, our team at Children's Mercy began building software applications that we think can address some of the concerns that I'm going to share. So um, this is in some ways it's a dated slide, but in some ways it represents technology architecture decisions that we still grapple with. In 2001, we all remember September 11th, but shortly after that, there were anthrax tainted letters sent to recipients throughout the country. That prompted our leadership at Cerner to request an initiative to um, do something that can help with reportable pathogen detection, help that reach public health departments faster. So I had the opportunity to lead that project and evaluated three technical options. One is what you could consider a federated approach, where you standardize the data at each location and then send that to the public health organization. The second is you send the raw data to the public health organization and let them standardize it. The third approach is to use what was then called a data clearinghouse. Now it could be a data warehouse or data lake or any of those iterations, but you centralize the data and then you send the summaries to the public health recipient. So that's the approach that we chose. It's still one that I tend to favor when making architectural decisions. We were able to, through that initiative, improve public health reporting by increasing data completeness significantly in the data that was reported through the system that we called Health Sentry. We reduced underreporting, so many even reportable diseases aren't consistently reported to public health. And most significantly, with regard to bioterrorism, we improved the timeliness from 2.5 days to a half day or less. Again, remember at that time, much public health reporting happened through faxes and other less reliable strategies. So we were able to really see a significant improvement by integrating and delivering that data to public health departments. A few years later, in what could be seen as a precursor to the public health crisis created by COVID, um, in 2009, there was a influenza H1N1 pandemic, and at that time, I was tasked to organize and facilitate a national surveillance initiative. So we recruited more than 850 facilities in 48 states through the client network, um, and began aggregating light packets of data every day from those organizations, delivered maps and daily updated graphics to those contributing sites. And again, that was very well received, but it also highlighted some of the tensions that we continue to see between federal and local public health in terms of how data is delivered to them. But again, this was a process where we had the opportunity to repurpose some existing data infrastructure for public health monitoring and surveillance. Um, Moving to the present, I want to share a little bit of some things on my mind about, and again, this is using the harnessing and unleashing metaphors, but are we harnessing and are we unleashing data, AI, technology, using the harnessing visual? Is there a driver in control? In AI, we talk about, is there a human in the loop? So I'm going to share a couple of examples that highlight why I'm concerned about this, why I think maybe we're doing a little too much unleashing. This is some background, and this is increasingly familiar to most of you, but some terms you'll hear a lot. You'll hear large language models, LLMs. These are systems that are trained on massive amounts of data. Increasingly, their interactions come close to seeming human-like. Generative AI, in response to a prompt or request, it can provide you an output. That output can be a text, an image, or a video. And then a model is the logic that informs and drives that LLM. It's sometimes as we're designing and developing these systems, when we talk about big data, it's easy to forget that big data is comprised of a lot of little data. And to the extent that there are flaws or gaps or challenges with that little data, those can propagate into the behavior of the larger system. AI in healthcare involves similar processes to other domains where you begin with training data, use that data to train your model, and then you use test data to test the behavior of the model. And then you start to engage a user in interacting with the systems connected to those models. And then new data can be brought in to continuously train the model. And so the behavior of a model today may be very different, or at least slightly different from the behavior of the same model tomorrow, because new data is introduced and that modifies the behavior of the model. And then this is a continuous cycle in which the data, the model, the testing should be continuously connecting together and informing one another. When I think about AI in healthcare, so there's source data. Many of the examples that I'm interested in use electronic health record data as the source data. So you may have a body of source data, and then you carve out your training data, pull that out of the source data, and train your model. Where I think it's easy for people working in this domain to get carried away is the models are only good as the data that are being used to train the models. So some well-known data challenges are incomplete data. So we have the data, but there's little holes in the data. We have missing data where records are not available. And then we have data that's not representative of the broader population. And these are topics that are strong concerns for me. My team here works a lot on addressing these issues. So I'm going to share some examples of how we go about doing that and how I want to encourage anybody listening to reflect on the sources of the data that they work with. So I'm going to share a couple of cautionary examples. The first example is actually not healthcare related. So visual classification is something that AI engines and applications have become pretty good at. So the three images here are of vehicles, a bicycle, and a person walking. The example I'm going to share is, so a vehicle is the fastest moving, bicycle can be fast, and then person walking is the slowest. So in addition to monitoring the image, AI systems can increasingly also monitor the velocity. So if you see a person walking a bicycle, then how should the image classification handle that? And this became especially important a number of years ago when a woman named Elaine Hertzberg was walking her bicycle across the street at night in Tempe, Arizona. And she was the first pedestrian killed by an autonomous vehicle, an Uber, because the AI couldn't classify her as a bike, a person, or a vehicle because she was walking her bicycle. Her Uber settled with her family, but she's considered to be the first pedestrian who was killed by an autonomous vehicle. But I think there's another victim in this story, and that is Rafaela Vasquez. So even though we like to currently think of autonomous vehicles as empty, Rafaela was actually in the autonomous vehicle as a monitor and was monitoring Slack messages as she was required to do by Uber while in the vehicle. And she probably responding to some pressure plea bargain to negligent homicide for her role in the death of the pedestrian. Uber was never held criminally accountable. And I think it's important to think about healthcare from the same lens. So if and when a AI-driven process leads to the death of a patient, what's the accountability for the provider who is engaging with and interacting with that AI? I think a really compelling paper came out last year that showed how widely utilized LLM languages can be very susceptible to subtle influences. And so the the authors of this paper used multiple clinical data sets, including some dialogues on Ask a Docs, a Reddit thread, USMLE cases, and other sources. And they made very minor perturbations in that content. So they might have swapped the gender or removed the gender. They may have added some elements of uncertainty to the text that was used to train the model. What was disturbing was that the clinical output presented by the same clinical content in which those other factors had been changed. In some cases, if the patient gender was changed to female, the system was 7% more likely to generate a manage at home recommendation. If uncertain language is added, the urgency of the advice became less urgent. Very minor typos in the content, reduced care recommendations. So I found it to be a powerful example of how these systems, the output is, as I mentioned, it's little data that becomes big data. And to the extent that there's factors and biases reflected in that little data, the guidance can shift on very minor changes. And when we talk about human in the loop, that assumes that the human in the loop will recognize the impact of these variations. And some of these changes would be subtle to a human reviewer and may easily pass their review. So these are reasons why I think when we talk about unleashing AI, we need to be really careful and more careful than in some cases I think we're seeing. Now, at the same time, I'm not an AI Luddite. So I also like to ask myself, what would have happened if COVID had been COVID 2009 instead of 2019? It would have taken much longer to identify and characterize the virus. So we had bioinformatics that was enabled by machine learning. Developing the rapid diagnostics would have been much slower. Modeling the spread of the disease would have been slower and less accurate. And the development of safe and effective vaccines would have taken much longer. When we really think about the dramatic timeline of 2020, the first US case was identified in January. We all think of, at least I think of March 13th as the shutdown date. By November, we had a rapid home test, and in mid-December of that year, the first vaccine was available. And again, I credit artificial intelligence and machine learning to playing major roles in this rapidly accelerated timeline from first US case to first vaccine. So I don't want anybody to take my concerns as coming across as a Luddite. So what can we do? The next themes that I'm going to touch on are strategies to understanding and profiling the input data used in your work. We like to imagine data as a well-oiled machine, but the reality for anybody who works closely is that there is often and should be, I believe, a person behind the curtain monitoring the data. The resources that I've used for most of the work that I'm going to describe is versions of the Oracle Health real-world data. Earlier, it was referred to as Health Facts. Our team also does a lot of work with Trinetics, and we're beginning to work with Epic Cosmos. And they all have some similar aspects to them. So getting back to this concept of different challenges that can be found in source data. A few years ago, we did a study with the Cerner Health Facts data where we profiled the contribution patterns of 100 health systems contributing to the data. And the spark graph shown here shows encounters over time. And then on the right, we pull out two health systems and look at the facility level. And the bottom line here is that if we hadn't taken this mindset, we probably would have assumed that all health systems were contributing consistently throughout the duration of the study or of any work done with the data. When in fact, there's all kinds of technical and operations factors that come into play that influence whether data from a particular contributor is making it into the system and then whether it's making it inconsistently. There are other explanations that you need to think about. So when we look on the right at the health system that has 8 facilities, sometimes health systems either buy a facility or divest a facility. So, for example, regionally, KU has acquired Liberty Hospital. So we see those divestment and acquisition patterns are business operations things that have a very tangible impact on these large scale data resources, but they're not always present or available as metadata. So you have to kind of back into recognizing those. We also know that if you try to work with this type of data and aren't familiar with how electronic health systems are implemented, you can also make some assumptions that would prove not to be correct. So EHRs are modular, and not every organization uses every module of the EHR. So we did a upset graph where we looked at the use of a subset of modules across the contributors, and we found very divergent patterns where, um, for the most part, most contributing organizations weren't using every module. Only 49, the group near the middle where you can see a dot for every category of module, only 49 facilities were using all of the available modules. So again, you have to really spend time to understand the nature of the data that you're working with, understand the workflows that generate that data before you can work consistently and accurately with that data. Another thing we found in profiling the data, so there was a policy mandate to driving the change for diagnosis coding from ICD-9 to ICD-10. Many people would understandably assume that that shift happened abruptly on the date that it was required, when in fact, when we profiled the data, we saw a much more gradual shift in the usage of these coding systems. And so you have to, even at that level, ask important questions about, for the system that we're evaluating, when did they make that shift of which diagnosis coding platform they used? When you're doing outcomes research, clearly one of the most important outcomes is death, and it is non-trivial to access mortality information in EHR data. In the system that we use, the health facts use discharge disposition. So if the discharge disposition was deceased, then we would be able to recognize that that patient did not survive. However, we evaluated the usage of that field and found quite a few contributing facilities did not use that particular discharge disposition. So if you're using mortality as your outcome, you have to confirm that that is indeed the process that's being utilized at each site, contributing to these large data sets. So I've shared some of the concerns. Now I'm going to share some of the work that we've done that shows the value of working with these resources once you carefully apply the mindset that I just described. So we have used these resources to look at different healthcare utilization as a proxy for how real-world clinical decisions are made. One project that we did, and this was a PhD student from UMKC, and she examined the data to explore how often are patients with sickle cell disease receiving an A1C test to either diagnose or monitor their diabetes. And if you step back and think about the biology, sickle cell is a disease that affects the structure of hemoglobin. A1C tests look at glucose bound to hemoglobin. And so if the structure of the hemoglobin is modified, the reliability of A1C as a test goes down. But that logic isn't always applied in clinical practice. And we found that of the more than 36,000 sickle cell patients in this data resource, about 11% of them had one or more A1C tests. There is a alternative test that's much more appropriate for patients with sickle cell, and that's fructosamine, but we only found a very low level of utilization of that test. Now, there are policy drivers that, in many cases, in order for an organization to receive certain federal incentives, you have to do an A1C test on everybody, and that doesn't have a exclusion clause. So again, there may be understandable policy drivers, but clinically, it shows a gap. Another example that we explored, we looked at opioid ordering for youth and young adults who present to an emergency department presenting with a migraine. And opioids are not recommended for migraines. And as we know, exposure to opioids can increase risk of dependence. We examined data from 180 contributing emergency departments and found that 23% of youth and young adults presenting with a migraine were given an opioid medication. Um, we were able to filter out, so Children's Mercy we know is at a much lower, it was probably 1 to 2%, but at the level of these 180 emergency departments, it was a widespread practice. And then that's the type of finding that the collaborators on this took that to national conferences and shared it with their peers in neurology. And hopefully it has informed change in practice. More currently, our team's working closely with collaborators at the University of California in Berkeley and at UMKC. And we're using these data resources to examine the epidemiology of fungal infections. This particular slide shows work that we've done to examine aspergillosis epidemiology over time. We were able to show 5% average increase from year to year and a spike in the prevalence after COVID with a disproportionate increase among Hispanic and Latino populations. Some states don't require reporting of various fungal infections, and so some of the work that we're doing here is the first ever large-scale analyses of these fungal infections for those states. So we're really been able to leverage our access to these data resources for a variety of research questions, and I'm just giving a few examples from our body of work here. I'm going to transition now to another topic. We did some work a number of years ago with the Center for Genomic Medicine at Children's Mercy, where they are performing what we call genomic answers for kids. It's a large-scale study. And we were curious to examine the recruitment patterns for that study using geospatial analysis. So Natalie Kane, a member of my team, who has geospatial expertise, did this manual analysis where she compared the residences of these 2,247 participants to the known social drivers of health for the same area. And, for those of us who are familiar with the demographics of Kansas City, you can see the recruitment favored the wealthier, less diverse suburban areas, and that the urban core is much less well represented in the study. The map on the right shows where, we know the population living below poverty level can be. And so this is a manual analysis that took substantial time and effort to perform. And so as we've thought about what can we do to make a difference in analyzing these large complex data sets, one thing we recognized is if we can take the process that she applied manually and make it more accessible to the wider research community, we will have done something to help with the representativeness aspect of these large data sets. So that leads us to the final part of my talk on technology development, where we want to build applications that matter. And through Frontiers, we have a really nice collaborative framework between Children's Mercy and KU, where if one organization develops an application, the other organization will receive it, pilot it, share feedback, and then we'll either release it through GitHub or through other mechanisms. And we've done that so far with 3 examples that I'm going to walk through. So the first is what we call GeoMarker, the second is Scale, and the last is the Health Device Portal. So there are a number of challenges with place-based analysis. The commercial applications that are used to do this, largely through Esri, are expensive applications, and they're also very complex. We recognize that generating that side-by-side comparison is a feature that would have a lot of value. There are open source geographic information system applications. Some of those require command line expertise that's not widely prevalent among the research community. And then it's not out of the question that many researchers might use Google to geocode. Google is not HIPAA compliant unless you have a business associates agreement with Google or Alphabet. And so we also wanted to promote a compliant approach to doing these activities. So we had 3 high-level requirements. One is to promote HIPAA compliance. The second is to generate a user-friendly geocoding application. And the third is to support visualization. So the first application is what we call GeoMarker, and it's built around one of those command line applications called dgauss that was developed by Cincinnati Children's. We provide the ability to input a file that contains a list of addresses and receive an output with the latitude, longitude, census tract, drive time, and other outputs. We added the ability to engage with this GeoMarker through an application programming interface, an API, and we added integration with our institutional identity management so we could use our single sign-on. So this is a screenshot of the front end that our users at Children's Mercy and now users at KU have a similar front end. And so you just submit your file into the GeoMarker application. We are able to use an administrator dashboard and monitor usage. We can identify heavy users, identify performance concerns with this. And then the output is a raw file that includes the address supplemented with the longitude and latitude. These are retail pharmacies, so there's no PHI in this particular example. So we recently were able to publish a paper describing GeoMarker. 17 employees at Children's Mercy have processed more than 2 million records using the application in 2025. And then the API version is getting even higher usage because our patient progression hub at Children's Mercy has been using some of the back-end capabilities. KU is also showing a high level of usage of GeoMarker, so we're really happy to see this adoption. And in kind of a full circle aspect, Cincinnati Children's that developed dgauss, they are in the process of using our GeoMarker wraparound to their technology. So GeoMarker is the first piece, but we also wanted a visual application that we can then pull in those geocoded features and present them to the users. And so we developed what we call the Spatial Cohort Analysis and Location Explorer, or SCALE. We've added a workflow that walks the user through the steps that they need to perform, including importing a geocoded file. And then this animation shows how we're able to engage with the locations that are included in that file. and include features like blurring so that we can protect the privacy of those locations, so that you can use these visuals in presentations and publications without violating privacy of the participants. And then the really powerful feature is the side-by-side comparison. So what was previously a very long and manual process, now users can compare in real time their cohort on the left with one of a variety of social drivers of health features on the right. And as you zoom in and out, the two screens stay in alignment with one another, offering the ability to do that evaluation in real time. So Scale is now in use at Children's Mercy for a variety of studies, and we're in the process of implementing Scale at KU. And then the last application that I'm going to just briefly mention is maybe a setup, because I know that Dr. Thompson's talking about wearables in an upcoming talk, but we've developed a health device portal that simplifies the process of integrating data from wearables. We've also used it for a very different use case, and that's with air quality monitors for a variety of CDC-funded projects that our Division of Infectious Diseases is performing with schools. So it has been used in diabetes, ADHD, and activity research as well, and it is also being used at KU. So my concluding comments, I believe that AI, data-driven research, as long as there's a writer holding the harness, a human in the loop, have tremendous potential to improve health. But there are some subtle issues that won't be caught by a human in a loop and need deep monitoring. One part of a much broader landscape of trying to address these concerns is to use applications such as those that our team is developing to profile data, identify whether the data is representative or not. And then finally, a shameless plug. Coming up in 2 weeks is the Nexus Informatics Conference. We'll be hosting it at Children's Mercy. Love to have any of you attend. We have some great keynote speakers lined up. Chetan Sarabu will be talking about climate health informatics, and Paula Ehrlich is the CEO of the E.O. Wilson Biodiversity Foundation, and she'll be talking about biodiversity informatics. So I hope that you go to the BioNexus website and consider registering for the conference. And of course, the people who make all of this possible are my team, as shown in this recent picture. So with that, I will stop, and I appreciate the invitation to speak. Thank you.
Thank you so much. That was a great presentation. If anybody has questions for Dr. Hoffman, feel free to raise your hand, jump in the chat, come off mute. We have a few minutes left, and you're welcome to ask your questions.
Hi, Mark. It's Paula Nichols, Paula Monaghan Nichols. Let me just turn on. That was a wonderful presentation. Thank you very much. I'm going to download your publication immediately. I just wondered to get your insider thoughts on use of AI in education, or students using it to like enhance their courses or develop questions for exams, etc.
Yeah. I think it can be helpful for overcoming writer's block, but it's just the beginning. What I don't like to see is anybody, whether student or I see faculty, I see experienced people exhibiting some sloppy behaviors and just accepting the output without careful review. So whatever you're using AI for, I recommend use it as the beginning, but then review it, make it your own, make it in your voice, and then maybe use AI at the back end to do touch up.
And a second related question for the databases that you showed at the end of your talk, the last two or three,
Mhm.
um, uh, are they easy to access and for a non-experienced user to go in and use them, or is there a significant training needed?
Yeah. Most of our work with health facts and real world data is performed by data scientists who are really proficient with the technical work. I always like to structure collaborative teams. So the subject matter expert, the data scientist, often a statistician. And so what I don't like is when I go to a conference and I hear somebody technical say, well, you physicians just need to learn how to code in R. I don't think that's the solution. So um, they can be difficult to use. We're in the process of learning Epic's Cosmos, and it has two flavors. One is a front end that is used as has a good user interface. Our team at Children's Mercy is very active in using Trinetics, which also has a very nice user interface. I'd love to see University Health adopt Trinetics, just because it is so useful. There's varying degrees of complexity in using those.
I think we have
So,
a hand raised.
Yeah, Mark, I was just wondering, with the scale maps, you're doing them side by side with kind of some of the social determinants of health things that it pulls. Do you guys have any interest or any capability to potentially pull in other environmental markers like parks
yeah.
and the thing? Obviously, we do nutrition and physical activity stuff, but those sorts of stuff to be able to map those things against things would be just awesome.
Um, we can have follow-up conversations. We are doing exactly that, where users who have a data set like that can import those other geographic markers and then do that side by side with whether it's green space or other things that, if you have a, a map, data that's ready to be imported, we're working to allow that for things that aren't fixed like our current version. See, Randy, I don't know the order though.
That's all right, Mark. I'll go ahead and jump in. So great presentation. One of the things that I like of what you did is you talked about the difference between harnessing and unleashing, and being in the regional conversation when it's related to AI. Is I often hear people tout the hype of what the AI tools are going to be able to deliver at some time in the future, whether we're talking about drug discovery, biomanufacturing, or clinical health outcomes. And I feel like you did a great job outlining the data problem that we have, the holes that we have, the misrepresentation or the lack of representation, or just incorporating data sets that don't align with that particular training set. So my question is this: how do we massage the conversations in the region to focus more on the critical needs, which is addressing the data problem, and
Mhm.
divert people from getting fixated on the hype, which usually ends up ending conversations because people are like, oh, it's already been solved. So, how can we do that better in our region?
Yeah. And this is a national challenge. My professional association is the American Medical Informatics Association, and now oh, probably 70% or more of the talks at the conference are AI related. Some of those are, um, hey, we got to be careful, but a lot of them are more in the hype category. But I think I'll give an example of something that worries me is when I come across, and I apologize if anybody fits into this category, but where a data scientist will say, just give me your data, I'll figure it out. And what I mentioned towards the end is I think we really need to demonstrate and promote that team science approach where if you have the data, collaborate, but don't just hand it over and wait for a nicely polished analysis to come back. It's got to be a constant interaction, and the nuances of the systems and processes that generate the data are all too often lost in those moving the data from raw data to incorporation into an AI model or analysis. So I think role modeling those good behaviors is a key part of what our region can do. We have a lot of former Cerner people like me. And even within a big company like Cerner or Epic, there's disconnects between the application and the data and that I often poke on because even within those organizations, there's not that consistent awareness. So I think role modeling those good behaviors is a big part of what we can do.
I have a question, Dr. Hoffman. You talked about applications in healthcare. Do you have something in pipeline or any success stories on genomics and multiomics front as that becomes standard of care for many treatments?
Yeah, and it was probably mentioned in my introduction. So I've also spent a lot of time in strategizing around how to integrate genomic information into the electronic health record. One of the realities that I've come across and Children's Mercy has a top-notch Center for Genomic Medicine, where we've sequenced, more than 25,000 people. But the usage of that information in routine care is still limited. There are areas like cancer and a few other areas where that we're starting to see that change. But I think to the extent that the strategies that we touched on in the presentation can be applied to any topic, whether it's standard clinical data or genetic or genomic data, I hope that to be the case regardless of the specific source.
We have time for a couple more questions if anybody wants to jump in. Or hearing none, we can wrap up and folks can finish their lunch breaks.
All right. Thanks again for the invitation.
Yes, thank you. And thank you to everybody for joining us. We'll see you next week with our AI and clinical and translational research presentation. Thank
Great.
you.
Thank you. Bye.